Today we will discuss about the paper machine numerical. This one is especially about the calculation related with the machine speed on paper machine and different parameters here. So first part is given here in the terms of the head box here. Right, for the calculation of the head box. And then the second numerical is about the manufacturing of paper which is having 120 GSM super printing paper with the given production capacity and the moisture percentage. So let us see here. This one is about the calculation of the jet velocity of a stock slurry coming out of the pressurized head box. That means how to calculate the requirement of the air pressure or total pressure at the base of the head box, especially in the pressurized tank head box. Similarly, again, depending on the requirement of jet velocity, you can find out the pressure that is required in the hydraulic head box. Let us see the complete numerical or the parameters which may be given here in the paper industry. A paper machine is manufacturing 120 GSM super printing paper with a production capacity of 360 tons per day with 5% moisture at drum reel of paper machine. So this speed is given at the drum reel of the paper machine here, that means after drying. When the decal width of paper at pop reel is 5.0 meter, calculate the speed of paper machine at which roll if the paper is being stretched by 2% and 3% in press and dryer section respectively. Again, calculate the jet velocity of a stock slurry coming out of the pressurized head box. Suggest suitable hydraulic pressure in head box at the base for getting this jet velocity. That means how much should be the total pressure at the base or bottom of the head box. So that may be the summation of the level inside the head box, that is the hydraulic level, the level at which the liquid is filled up, then extra pressure that is generally provided with the help of the air pressure. So total pressure can be calculated here, and then you can calculate the air pressure. So let us see the steps here. The production capacity in terms of the oven dry mass that can be calculated from the given was having the 95%, so we are multiplying the total mass with 0.95 and it will be giving you the 342 tons per day. And for simplicity of calculation for the speed, we have to go for the smaller dimension, that means place of day we should be going for the per minute production. So ton will be multiplied by 1000 to give the kg, and in day we are dividing it with 24, then it's giving the hours, and then again divide by the 60, so it will give the per minute. Right, so it will be 340 into 1000 divided by 24 into 60, and that will be in terms of the kg per minute. So if you do the calculation here, or then it will be coming to 37.50 kg per minute. And this is equal to, again, in terms of the gram, 237.5 into 1000 will be the gram per minute, and this will be the value in the gram per minute here, 2,37,500 gram per minute here. So this conversion has been done for the simplicity of the next calculations. Let us have the another parameter. The decal width of the paper machine is 5 meter. That means whatever the paper we are producing, it's having the width of 5 meter. So the speed of the machine at the top reel that can be calculated. This is the production rate here in terms of gram per minute, and you can see if we are dividing it by the width of the paper, then production rate in gram per minute, that means the mass flow is given divided by the width here. Again, we are dividing it in terms of the meter per minute here. You can see here, right? So why the 120 is coming? That is the question basically. Why we are dividing by the 120? Again, because here the production is given in terms of the gram per minute, and the GSM of paper is given here. So again, you have to see the GSM of paper. GSM of paper is given, and that is basically having the value of 120. That means, what is the meaning? The meaning means it's a gram per square meter. So GSM stands for gram per square meter. Right? So GSM will be equal to the gram per square meter. Right? And that's why we are dividing it by the GSM here. So once we are dividing by the GSM, that means the gram per minute divided by gram per square meter. It will be in terms of the area of the paper produced. That means meter square per minute. Getting it? Once it's a coming meter square per minute, then again we are dividing by the width of the paper in meter. So finally it will be coming, the unit will be meter per minute. Getting it? And that's why we are dividing it by 120 first of all, GSM, and then we are dividing by 5, that is the width of the paper. So mass flow rate divided by GSM divided by width, that will give you the velocity or speed of paper manufacturing, 395.83 meter per minute. So that is the point here. As the paper wave is stretched by 3% in dryer section, it's given in the numerical. The paper is being stretched generally in the race section as well as in the dryer section. It is a stretchable material in the wet condition. It's having the good elasticity. So it will be stretched. Normally we are taking the average figure of the 3% as per assumption and given in the numerical here. The real figure will be intensity will be nearby to same or slightly varying depending on the structure and design of the machine. So the speed of the paper at the entry to the dryer, that may be taken here 100 by 103 into 395.83. Again the question will be coming, why we are multiplying by this figure 100 by 103, because it's being stretched by 3%. The initial speed is 100, so it is stretching by 3%, final will be 103, right? And that's why 100 by 103 multiplied by the speed at the top reel, that means at the end of the dryer, that will give the initial speed, right? So it will be coming 384.30 meter per minute. Again, paper is stretched by 2% in the press section. So the speed of paper at the entry to the press, and that will be nearly same to the push roll. So paper is leaving the push roll on wire section, and then it's being picked to the press section. That means from push roll we are picking it and taking to the press section. So at this point the speed will be 100 by 102, just like the previous one. 100 is at the starting of the press, 102 at the end of the press, right? And the speed at the end of the press is given, it's 384.30, because when it's ending the press section, it will be entering to the dryer section. That means at the entry to dryer and at the end of the press, it will be having the nearly same speed, and that's why we have taken the 384.3 here. And finally, if we do the calculation, we will be getting 376.76 meter per minute. That means from the start of the press section to the end of the press section, there is a stretch of 2%, and that's why it's a stretching by 2%. We have taken the figure 102. Right, so that means that starting the speed will be slightly lower in comparison to the at the end of the race section. So it is coming 376.76 meter per minute. As the ideal ratio of jet velocity to wire speed is 1, Normally, most of the machine we are maintaining the jet to wire ratio nearby to 1. Right, so we'll be taking here the jet to wire ratio 1. So again, we'll calculate the jet velocity. So the jet velocity will be equal to the wire speed, and this is nothing but the speed at the push roll of the wire section of the paper machine. And this will be equal to 384.30 meter per minute. So you can see here the basically the jet velocity is equal to the wire speed, right? And this wire speed is really again equal to the speed of the push roll. So this figure should be taken at the 376.76. So it will be 376.76 meter. And then you can do the conversion here for the meter per minute to, you can go for meter per second. Right, so for getting the meter per second, we have to divide it by 60. So let us do the calculation here. The 376.76 divided by 6.4. So slightly having the deviation here. So that's why we have to do the correction here. 376.76 divided by 60. This will be coming 6.279. 6.279, that means it will be nearly 6.28 meter per second, right? Once we are getting the jet velocity, that means at this velocity, the stock slurry will be coming on the wire. So this is the velocity at which the jet will be coming out of the head box. That is nothing but a pressurized tank, right? So you can apply the concept of the fluid mechanics. Flow from a rectangular opening at the bottom of a tank, which is having the internal pressure, or closed tank having the pressurized condition with the help of the, you can say, the extra air pressure. Right. So by applying the concept of the fluid mechanics, you can see here the velocity V can be given by the CD multiplied by 2GH raised to power. The very common equation. Normally we are finding the value of the velocity as the under root 2GH. So for more correction, we are taking the one factor coefficient of drag generally. The coefficient of drag is taken here. That means it will be slowing the velocity slightly by a small fraction. Generally the CD is the 0.98. That means the nearby to 2%. You can see there is the effect of the drag. It will be slowing the jet velocity, and V is the jet velocity, H will be the head or pressure. This H is given in terms of the head or basically height of the same liquid in terms of the meter generally. Depending on the parameters taken in SI system, it will be in the meter units. So the pressure is shown by in terms of the height of the same liquid. So if you are filling the tank for the certain height, it will be exerting the pressure at the bottom, and that will be taken as the head here. And G is the acceleration due to gravity. Its value you already know. So now put the equation here. We have to find the H here. So H will be nothing but V square divided by 2G, again divided by the CD. That means H will be here, CD will be coming on this side. In the lower part, 2G will be again going to the lower part of the V square. So put the values of all the parameters given here. So here we will be taking the 6.28 velocity here. So now see how much figure we will be getting. 6.28 into 6.28 here. Then divided by 2. Again divided by 9.8. and again divided by 0.98. So this will be coming, having the correction here. That's you can do the calculations depending on different parameters and see the values here. Zero 0.98, so it's coming 2.05 meter nearly. 2.05 meter here. Then you can do the conversion here in terms of the different units. Depending on the density, we can assume the density nearby to 1000. That means the water, or if we are having the more quantity of the pillars, we can increase also here by some parameters. So generally it will be nearby to 1000 kg per meter cube. So you can do the calculation here and find out the pressure. Right, so you can see the step here. So you can take the pressure, it's coming 2.05 meter multiplied by 1000 multiplied by value of G. That is the pressure in terms of the SI system, that is the kg per meter per second square. So let us see the value, how much it will be coming. 2.05 multiplied by 1000, again multiplied by 9.8. So this will be coming. This is coming 20,090. Right, so 20,090 kg per meter per second square. And if you are again doing the conversion here, that means how much will be the value here? How to convert into the Newton? Right, so you can take this figure and simply will be converting in terms of the Newton here. So anyone can tell the figure here how to convert this one in terms of the Newton? So Newton is nothing but kg meter per second square, right? Kg meter per second. By seeing the unit, you can see here it's a kg per meter per second square. So basically, you have to multiply by meter here, and it will again be multiplied by meter here, right? So you can see here, once we are multiplying here, the value will be kg meter per second square. That means again you can write down here for simplicity, for understanding the conversion to Newton, because most of the industry you will find the pressure is given in terms of the Pascal here, right? So it will be 20,090, and we are taking the unit here, kg, multiply by 1 meter here. Just number 1 kg multiply meter here. So in the denominator again, we will be multiplying by meters, it will be meter square, right? So it will be meter square here, and once it's a meter square here, rest to the second square will be coming as it present here. You can see here, so second square is coming here. So what are the units now? Now you can say the kg meter per second square is nothing but Newton. So this will be equal to the same unit will be coming here. Right, so it's a Newton per meter square. So here again the figure will be changed. It's 20,090 Pascal. Newton per meter square is nothing but the Pascal. So can convert in terms of the kilopascal again. In kilopascal, it will be divided by the 1000. So the value will be 200.9 kilopascal. If someone is saying how much kg per centimeter square pressure is given, Again, generally 10 to power 5 Pascal is equal to, or 100 kilopascal is equal to 1 kg per centimeter square. So you can see here, this is again equal to how much value? Again divided by 100, so it will be the atmospheric pressure or equal to the 10 to power 5 Pascal. Right, so this figure will be 2.009 into just multiplied by 10 to power 5. 10 to power 5 we can take here in terms of the power here, and now the unit will be Pascal here. You can see the convergence, and large number of industries they are having the different types of the systems. Some are basically taken from the Europe. You'll find they are using the gram, centimeter, font system again. Some are taken from the American, then they are again using the generally SI systems. In Indian manufacturing industry also they are using the SI system. So in this way you can find the different parameters here. The kilopascal too we can convert into 10 to power 5 Pascal. You must be knowing 1 into 10 to power 5 Pascal generally equal to 1 atmosphere or 1 kg per centimeter square. That means this head box is required to have the total pressure nearby to this one. So there is a one action will be required here. So basically we are converting to 1020.09. So it will be only equal to 0.209 here. So basically you can do the conversion, take the value nearby to 1. 0.201 into 10 to power 5 Pascal. Right, so that means 0.2 kg per centimeter square pressure is basically required here, kg per centimeter square. Okay, in this way you can do the different types of the trials and do the conversion of the units. Again, use the basic concept of the fluid mechanics here. And sometimes we are having the coefficient of contraction also in some calculations. So this is all about the calculations related with the head box. So depending on the machine speed, you can do the calculation for getting the total pressure inside the head box. Again, if the pressure is given head box, then you can find out the jet velocity, and similarly you can find out the velocity of the machine in the different press section and the drag section. So you can do the number of manipulations and change the figures depending on the different industry, and then you can find out the different answers here. So you can make a table basically. Do the different types of the calculation depending on different grades. Normally the lighter grades like the tissue paper newsprint will be having the very high speed. Generally machines are running even up to 800 to 1000 meters per minute. And if we are going for the specialty grade of paper, then we are having the lower speed. So if you are making, for example, the transformer paper or the capacitor paper, then the speed will be lower here because it's having the very high hydration. So removal of water is very difficult here. So depending on the higher refining, the drainage is difficult. So its degrees are very high. So I mean the very less drainage, and that's why we have to run the machine at the lower speed. So in this way, you can take the different parameters from different industries. It's given in the website of industry. The machine running speed, GSM, and the width, the appropriate width will be again given there, and you can do the calculations. So that will give the idea about the different industries and how to do the calculation, optimize the value, because it's for engineers are very much required to do the calculations. It should be proficient for getting the optimization of the process parameters. So that will save the money. For saving the money or generating the money, paper machine, we should have a lot of the calculations, and that will be helping in optimization of the process and reduction in the input parameters or input cost. Okay, thank you, and here only.